to see about that communication processor to memory communication. Okay, processor to memory communication. Take this here. This is the primary. Okay, here is the processor and here is the memory. So first is read operation. Reading from the memory. Reading data from memory. So what first processor will do, whenever it wants to read from the memory, what first processor will do, it will place the address of the location. From the memory it has to read. So which location it has to read? So first it will place in the address bus through via memory address buffer. It will place in the address bus. Okay, place the address in the address bus. So it will place the address here. Okay, in the address bus. Okay. Then what will happen? Then it will issue the command, read command via control bus. So what will happen? It will place the address bus in the address which location it has to read, particular location, and it will issue also the read command via control bus. Okay. Now that particular memory location will be selected, and since it is the read command is given, so the memory will place the data in the data bus. So the data bus, via data bus, it will come to the memory buffer register. From the memory buffer register, here is the intermediate memory buffer. Via data bus, it will come to the memory buffer register and it will go to the processor internal registers. Okay. So after read command, data will be placed. Data bus. Okay, this is the way to read from the memory. Okay, these are 4 steps actually. So it will wait till here is the problem is that memory and processor speed mismatch is there. So memory is 10 times slower than the processor. So what will happen? It will place the address in the address bus, and it will issue the read command. So after that it has to wait for some time. Because why it has to wait? It has to wait because memory is slower than the processor. So it will wait for some time. It has to force to wait, and it will wait for some time. After some time, it will place, after some time in some cycles, the memory will place the data in the data bus from the corresponding location. Okay, these are the 4 steps involved in the read operation. Okay, similarly write operation. So now we are reading from the memory to the processor. So reverse, writing data from processor to memory. Writing data to memory. Process is same. So which location it has to write, which memory location it has to place the data. Processor will place first. So address where it has to place the data from processor. Okay, then it will issue write command. Wait command, it will issue write command, and at the same time processor, because data has to go from processor to memory, so data also it will place. Data, wait till it completes. Okay, see, these are the 4 steps. See, processor will place which memory location data has to be written, address. Okay, and it will also place the data to be written in the bus, data bus, and it will issue the write command. Okay, it will issue the write command because this process will take, this is slower, so it will take longer time, so the processor will wait till this process is completed and data bus and address bus are occupied. Okay, you understand? First it has to write to the memory location, it has to specify the memory location where it has to write, and secondly it has to issue the write command, and thirdly data has to be placed in the data bus because data has to be written from the processor, and it has to wait for some time because memory is slower than the processor. Okay, this is the way we write, and this is the way we read, and this is the way we write. Okay, So since there is a lot of mismatch between processor and memory for writing and everything, so there is another thing in since there is a lot of 1 to 10 times speed mismatch. Okay, 1 to 10 times speed mismatch between processor and main memory. So there is a lot of time of processor is wasting in the waiting mode. Okay, so instead of in order to reduce, there is some solutions are invented actually. So a cache memory is nothing but this is cache memory is faster than the main memory. So read write time of the cache memory is very less. Okay, so what will happen usually? Okay, cache memory means a block of data and instructions, because programs usually executed in the sequentially. So a block of data and block of instructions, that means data, there are two types of caches, data cache and instruction cache. So a block of data from main memory to is fetched and placed in the cache memory, because cache memory is faster than the main memory. Okay, here we are getting a sample, a temporary, a block. Okay, block of instructions and data is placed in the cache memory. Okay, the processor first initially check in the cache memory, usually 90% of the times. Okay, it will get the instruction in the block itself. Okay, next instruction to be executed will found in the cache itself, because unless there is a jump instruction, jump means it has to go from some different location, it has to go from current execution location, sequential location, to it has to go to some particular location where the jump instruction has to run. For example, C. This is the main memory. Okay, these are sequence of instructions. Okay, usually instructions are executed sequentially unless there is an instruction where it specifies that it has to jump to this location. Okay, and fetch the instruction from this location. What will happen in this case? Usually what will happen in this case, there is a jump instruction, because current instruction location it has to jump from some other location. Okay, usually in that case jump instruction we are not able to find in the cache memory. Only at that time only it will fails. Again it has to go to the main memory and fetch the instruction. So processor has to go to main memory and fetch the instruction, or it has to, from the main memory it has to load to the cache memory. Okay, so what will happen in this case? So unless 90% of the times whatever data we require will found in the cache, so that cache memory is created actually. Okay, cache memory speed is very much faster than the main memory. Okay, so there are nowadays actually two types of cache, L1 cache and L2 cache. L1 cache is much faster because L1 cache is placed in the processor itself. Okay, L1 cache is placed in the processor itself. What does it mean? It is placed in the processor itself actually. So there are two types in L1 cache, instruction cache and data cache. Okay, similarly L2 cache is placed in the outside the processor. Okay, the size of the L1 cache and L2 cache, because L1 cache is inside the processor, it is very less, very small size compared to the L2 cache. Cost wise L1 cache is more costly because it is inside the processor, so its speed is more, so that its cost is more. Okay, for byte, cost per byte you have to remember. Okay, so L2 also two types, data cache and instruction cache. Okay, using this cache the program execution speed and time mismatch between processor and main memory to fetching the instruction data is reduced. Okay, in this way the execution speed is and speed mismatch between processor and main memory is reduced using this cache, L1 and L2 caches. Okay, so L2 cache usually will use, main memory usually is DRAM. Okay, L2 cache is usually SRAM. Okay, we'll study more about it while studying in the RAMs. Okay, dynamic RAM and static RAM. Okay, this is the way. Cache is an intermediate between the processor and main memory, whose speed is more, and most of the times we will store in the cache line. You have to see the cache line is nothing but block of instructions stored in the cache. Okay, block of instructions or block of data. Okay, that is called cache line. Okay, usually processor searches in the cache first. If it fails, then only it goes to the main memory. Okay, if it fails, again it will load from the main memory to the cache, and processor will pick up. Okay, the failure rate is very less, 10%. 90% of times, most of the times, cache will hit success. I mean, it will found the data in the cache itself, whatever the data required or whatever instruction required. Unless there specifically comes a jump instruction, then only cache fails. Okay, it has to go to the main memory. Okay, this is the way cache is an intermediate between main memory and processor to reduce the speed mismatch between main memory and processor. Okay, now we are going to study about that input output device to processor communication. Okay, this is the basic circuit diagram. So there is an intermediately an interface will be there, so that it coordinate the communication between input output device and processor. Okay, see how will it happens actually. So first we'll go to the device. Device will, for example, take the hard disk as the device, and device and its controller. Device controller means like hard disk controller. What will do? It will place the read write head at appropriate location, and it will give a command such that it will place at a particular location and it will give the data like that. Device and its controller. Okay, then its interface logic unit. Okay, it's an intermediate between processor and device controller to make the input output communication easy. Okay, you should also know that input output device and processor is input output device is 1000 times slower approximately than the processor. Okay, you understand that. So how the processor happens? So here is the see that processor can read memory directly access data bus, control bus, memory address. This is the processor to memory communication. Okay, this is the processor to input output communication. What will happen? So whenever a processor wants to read from some particular input output device, okay, it will place the address of that particular input output device in the data address bus. Okay, address of the input output device. First what will happen? It will place the address of the input output device for reading operation and issue a read command, okay, to the interface unit. Okay, so interface unit, what will happen? Interface unit will, what will it do? It will do what will immediately, so it has got some work, because processor is issued a read command from and the address of the particular input out, because there are multiple input output devices connected to this. Okay, so processor has to specify which input output device it has to read. So interface, it will place the address. So what will happen? Interface got some work because it has to read the work. What will immediately do? It will set the device is busy, because what will happen if the interface set the device is busy? It doesn't accept any further read command from the processor. Okay, so that still the existing operation completes. Now what will the interface unit will do? It will select the device, particular device, and issue the address of the location command signal to that control. This is control device command signal and device data. Okay, device control signal, device control. So interface unit next what will do? It will set the device busy flipchart and select the particular input output device and control issue the to that particular controller data to be placed. Then it will wait, this device will wait till the device controller places the required data in the register. Okay, buffer, internal buffer register. So now what will happen? This controller will place the data in this register, and what will happen? There is a command signal that data is now, after placing this from the data, whatever data required from the device, it will place in the interface register. Okay, after that, now what will happen? It will set the data ready, because data already placed in the interface. Okay, till then what the processor will do? The processor will continuously check this data ready flip-flop. Okay, till this is set, it waits and continuously checks till it gets set actually. Okay, once it is set, reads the processor knows actually, so data is ready. So what the processor will do? It will read the data from processor here to the register, internal register. It will place in the register, and it will acknowledge it. It will acknowledge the interface, acknowledge that it received data from here to here successfully. So after receiving the acknowledgement, what will do? It will reset the, because transfer is successful, again it is ready to take. So it will reset device busy flip-flop. Okay, and data ready flip-flop. Okay, you understand? This way the transfer happens between. But here that the processor has to wait lot of time because it is 1000 times slower. I mean, input output device is 1000 times slower than the processor. Okay, you understand? Processor issues a command, read command. So read command, processor issues read command and address of input output device to the interface. So what will interface will do? Interface will set the interface device is busy flip flop first. Initially it will set the device busy flip flop and it will give the command to the corresponding input output device. Next what will happen? The corresponding input output device will place the data in the intermediate register in the interface and it will set the data ready flip flop. Till then processor will continue check data ready flip flop. Once it is set, it will read the data from the processor to processor register, interface to processor register. After reading this, it will acknowledge it interface that data had been read successfully. After that, it will reset this busy flip flop because already data completion is taken place. This way, the data transfer happens between input output. Earlier, we have studied that data reading from the input output device using that interface unit. Okay, but that is much slower because processor keeps on checking. So in order to avoid that method, there is another method which is more efficient than the processor reading and waiting. That is program control interrupt data transfer. Interrupt data transfer is nothing but the programmer, because for example processor is executing or programmer is designing the program. Okay, he reads, he estimates, instructions are there. Okay, instructions are going on. So he estimates at some point of time data has to be read from the here, for example input output data has to be read by this point. Okay, what the programmer will do that he will estimate the time ahead of the time. Okay, so that by the time this instruction comes, the input output data is already read. So the processor what will do that in that case, the processor will issue the read command to the interface unit ahead of this instruction. Before coming itself, it will estimate by this time it will require this input output data, so that it will issue the read command from this particular input output device ahead of the time. Okay, it will issue the ahead of the time. So it will issue, for example it will issue the read. Okay, actually it has required the data here at this particular instruction execution input output data, but before that itself it will issue that read this particular input output data to the interface. Okay, interface you have already read. So it keeps on executing these instructions meanwhile. Okay, meanwhile what will happen, that interface will read the data from the input output device. What are the interface will read? The interface device processor. Okay, processor will keeps on executing these instructions. This issue the read command. Okay, what will happen, meanwhile this keeps on executing these instructions. Okay, now when the data is ready in the interface unit, what will happen, it will issue an interrupt signal. So interrupt signal, what does it indicates? It indicates the data is ready, processor can do. But at that time what the processor is doing, it is executing some instructions. For example, processor is somewhere here, it not reached up to this point. What will happen, it will suspend current instruction. Okay, it will stop the execution of the current instruction. When it will complete the current instruction, it will stop the execution of next instruction. Instead of that, what will happen, it will collect the data whatever ready in the interface unit and it will place in the internal registers. Okay, internal registers. After completion of this data, what will the processor do? It will start where it stopped. It starts from the where it suspended the execution. Okay, in this way interrupt controlled data transfer. Here what you have to remember is that here the processor is not wait. Earlier case what happened, processor is waiting for the data is ready. It keeps on checking data is ready flip flop. But in this case it is not waiting. It just issues the command and it's continuing the execution of its instructions. Okay, Only when the interface device is interrupted, crossback data is ready, then only it suspends current execution of the instruction and reads the data. After completion of the reading the data, again it resumes from where it is suspended. Okay, this is more efficient than the earlier version. Okay.